Hello everyone, today we are going to go over the blind 75 in C++, and today we are working with the problem serialize and deserialize binary tree. So, before we get started, now mind you, what we will be doing is that we're going to be filling in these two types of functions for serialize and deserialize, so I'm going to provide just the steps that we need for each function accordingly, and then, without further ado, let me just put them over here. So, to break down the question, serialization is a process of converting a data structure or object into a sequence of bits so that it can be stored in a file or memory buffer, or transmitted across a network connection linked to be reconstructed later in the same or another computer environment. Design an algorithm to serialize and deserialize a binary tree. There is no restriction on how your serialization/deserialization algorithm should work. You just need to ensure that a binary tree can be serialized to a string, and this string can be deserialized to the original tree structure. Clarification also, the input/output format is the same as how Leetcode serializes a binary tree. You do not necessarily need to follow this format, so please be creative and come up with a different approach yourself. Okay, so for what we will be doing for our following steps is that, for one, we are given the root of a binary tree as our input, so I'm just going to label out the rest of our following questions over what we need to do, so we know exactly what our input is, the root of the binary tree, what data structure/algorithm/technique to use, what to do with the data, and finally, what our output is going to be. So we're given the root of the binary tree. It looks like from our input to output, our output for serialization, we need a string that encodes the structure of the tree. For deserialization, the root node of the reconstructed tree. So then the technique that we're going to be doing for this, since we're focusing connectivity of a given tree, is that we're going to do depth first search using recursion for both serialization and deserialization. And so the steps for us to be able to go about for each one are going to be the following. Over here, for two functions. I'm going to put these notes in the comments as well. Is that for serialization, we will overall traverse the tree in pre-order traversal and build a string representation using essential value for null nodes. For deserialization, we use the pre-order string representation to reconstruct the tree, creating new nodes for each value and null for the sentinel value. So the steps for us to be able to work with serialization are going to be the following. If the node is null, we will return a sentinel value. Otherwise, we will return the string representation of the node value followed by the serialized strings of the left and right subtrees. And then for deserialization, we will split the string by the delimiter to get a list of node values and create a helper function that if the current node value is the sentinel value, return null. Otherwise, create a new node with the current node value. Then recursively build the left and right subtrees and assign them to the node. So, going over serialization, what we will need to do is that if we are at the root, for instance, and the null, and we are at null, what we will do is that we are going to return actually this value, which is going to be represented in the sentinel value. So it's just going to be the character of X with the space, and then we're going to return the string representation of this. So this will be step 2. Return to string root val plus serialize the root to the left and serialize, literally doing recursive calls, to the right. All right. And then to deserialize, we're going to do the following. Step 1, step 2. Is that we will have string stream in data, and then we will return a function that we create, my deserialize value in, which will be referring for over here. This will be step 2. And we're going to create a function that we will call. Using a helper function. So the helper function that we will have will look like this. Since we're working with the tree node, I'm going to deal with this helper function for deserialization, and there we go. The steps for us to be able to create our helper function for deserialization, transferring the data from one format to another. Since we're transferring from a tree all the way to a string, the helper function is going to have the following steps. Is that if the current node value is the sentinel value, return null, and then otherwise create a new node with the current node value, then recursively build the left and right subtrees and assign them to the node. So the way we're going to have them about is going to be this. So step 1, step 2, if val is equal to x, we are going to return a null pointer, much like what we did above. And we will create a new node, tree node. Root equals new tree node, stoy val. And we'll take the left with a recursive call. With what value we have with the given node. Make sure there are semicolons. Finally, we return the root. So let me just run this. Oh, we have an error. Okay. To initialize what we need up here, is a string called value, and make our data of n the value we will evaluate. So that means in particular for entirely of step 1, we have 2 and 3, and I'm going to have all the corrected ones in the description. String val in val. There we go. That should work. Stand corrected. Make sure there's a space. There we go. Passes all the test cases. Let's submit. All right. Now let me just expand this further. Just gonna move this up for you folks. There we go. Now seeing the whole solution that we will have. So to give a breakdown on our space and time complexity for our following solution is that the time complexity is going to be O of n, given the fact that we are traversing a binary tree using depth first search, since each node is visited at least once. Meanwhile, the space complexity of our solution is going to be O of n, given the fact that n is referring to the size of a serialized string when returned, and that's really just the scope of what we are doing, because we need to convert our given string data all the way back to a tree. So yeah, this was Serialize and Deserialize a binary tree. Thanks again for taking time to watch this. If you found this helpful, feel free to like and subscribe. And if you have any other questions, feel free to put in the comment section. And as always, take care. Cheers. Bye-bye.